All right, guys. I definitely appreciate you and your patience in me getting these videos done. I've had some major technical difficulties over the past few days. So what I've decided to do is instead of creating one long video, is that I'm going to break them down into smaller videos. When I was here in my office working over the weekend, I recorded one 15-minute video only to go back to see that my screen. I shared my screen and it was the wrong screen that I was sharing. So I hope that in doing the shorter videos, I can maneuver, move things around the way that I'm supposed to, and you can actually get what it is that you're supposed to get. So this is a series of videos for T-Test. There's going to be 3 of them. The first one is just me walking through a PowerPoint, just providing some additional information about T-Tests, what they are, when we use them, and the different types of T-Tests. And then the second video, I will actually walk you through JASP and how to upload your data, what buttons to click. There's a lot of buttons you can press in JASP. So I want to make sure that you are clicking those that are relevant for the homework assignments that you'll do, but also only clicking those buttons that you'll need if you're even doing research and publication. There's some amazing things that JASP can do. But in terms of what we really and truly need for most of the things that we'll do, there's only a few buttons that you'll need to push. So I want to make sure that you know what those are so that you're not overwhelmed or you're not confused with all of the additional data that JASP can provide. And in the last video, I will actually walk you through the APA write-up. So what should this look like? What information should you report and how you should report it? The good thing about APA write-ups is that they're very formulaic. There is a way to do it. This is the way you will always do it. So whether you're doing homework assignments or again, whether you're submitting things for publication, this is the way that it needs to be done. It's very simple, very straightforward. So I hope that in the series of videos that you will understand not only what you need to do for the assignment, but just really and truly understand what T-tests are, how to interpret the results of T-tests, and then how to write up the results of T-tests. So I am going to see if I can share my screen, hopefully share the right screen, and get us moving from there. All right. So if I have done this correctly, what you should see on your screen is the very first page of a PowerPoint presentation, and it should say T-Test Overview. So I'm going to trust that we are all there, and we're going to move through this relatively quickly. Let's see. Maybe not. Okay. Let's see. I think I got it this time. All right. So again, your first screen here should say T-Test Overview. Oh, it is still not doing what I need it to do. Let's stop this and try it one more time. Okay, so maybe third time's a charm on this one. Let's see if I can get the screen pulled up now. Let's see what we can do. Okay, I think this may be it. All right. So your first screen should say T-Test Overview. So let's move really quickly through this. Okay. So as we know, a T-test allows us to test the null hypothesis of 2 groups. So T-test 2 groups, right? And so basically what we're doing here is that we are comparing the mean of one group to the mean of 2 groups. So with a T-test, that's all we're doing. That's all we ever can do. Again, we're looking at 2 groups. We're looking at the mean of scores, the means from an assessment. But again, we're taking those 2 means, the means of 2 groups, and we're comparing them one to the other, right? So again, we're comparing males and females. We're comparing red hair, blue hair. We are comparing brown eyes to green eyes. But again, 2 groups. And what we're doing then, again, is taking the data points from each of those 2 groups. We're calculating the mean, and we're taking that mean, that one mean from group 1, that one mean from group 2, and comparing one to the other to determine whether or not there's any statistically significant difference between those 2 groups. So if you remember from the very beginning of the semester, we talked about how to calculate the mean. So let's say we're doing the red hair, blue hair group, and we've given them a spelling test, right? So we will take all of the scores for the individuals with red hair. We're going to add that up. We're going to divide it by n. Remember, n is the number of individuals who are in the red hair group, and that's how we calculate the mean for that group. And then we're going to take all of the numbers for the individuals who are in the blue hair group. We're going to add all of those together. We're going to divide it by n, the number of individuals in that group, and that's how we calculate the mean. So it's a very simple analysis, right? Calculating the mean and then comparing those two groups or those two means one to the other. And in this, we're testing the null hypothesis. So again, kind of going back to the very beginning of the semester, when we talked about the null hypothesis and the alternative hypothesis. Well, our null hypothesis states that the mean of group 1 is equal to the mean of group 2, right? And so in any statistical analyses that we're performing, we always start with this assumption. So the results that we get are either going to prove and accept the null hypothesis, which again states that there's no difference between the two groups, or we're going to reject the null hypothesis and accept the alternative hypothesis, which says that there is a difference between the two groups. Now, the null hypothesis and the alternative hypothesis do not give us any indication of the degree of difference. It doesn't even tell us whether or not the results are statistically significant or not. All it does is tell us that these two groups are equal, hence the null hypothesis, or that these two groups are not equal, hence our alternative hypothesis. So the assumptions that we make when we are anticipating or we're using a t-test to analyze our data is that we assume that we have conducted a random sample from a larger population. And so again, we talked about the importance of random sampling. We're wanting to make sure that we've given all individuals who would qualify for our study an equal opportunity to be a participant in that study. So it's impossible for us to test everybody who would fall within that particular population, right? So what we do is that we take a random sample from that larger population. One of the things that we think about, or one of the things that we like to do when we're running any kind of analysis, is to make sure we have as large a sample as possible. So again, we can't test the entire population, but how much of that population can we include in our sample for our analysis? One of the things that we do know is that the larger the sample size, the much more likely we are to find statistically significant differences between those two groups. Okay? We're also going to assume that we have a normal distribution. So again, kind of thinking back to the very beginning of the semester when we talked about the bell curve, and we talked about how we plot or how we can plot data on this bell curve. And typically what we see is this distribution of scores as they move from the mean towards the, the positive side of the mean or towards the negative side of that mean. So we talked about, 1, 2, 3 standard deviations above the mean, 1, 2, 3 standard deviations below the mean. Of course, this goes on forever and ever and ever. But the vast majority of individuals in our study, in any population, will fall between 3 standard deviations below and 3 standard deviations above the mean. But when we have a normal distribution among our population, we can be comfortable in selecting our alpha level or a p-value of 0.05. So this is the p-value that's typically used in social sciences research. That's not to say that that's the only number that can be used, but this is typically what's selected when we're looking at research and education and counseling and so on and so forth. We're also going to assume that there is some homogeneity in terms of variance. Now, people differ one from the other, right? But we want to make sure that there's some commonality among this group. Like we wouldn't want to compare the math scores of second graders to the math scores of individuals who are in college. Even even though we're looking at math scores, there's too much variance, right, between those groups in terms of age, in terms of opportunities to learn higher levels of math. So we do want to make sure that there is some level of commonality among the group, even though we recognize that folks differ, so that there will be some variability. So kind of looking then at variance and its relationship to standard deviation, typically what you'll see reported in academic journals and in most of the research that you'll read is the standard deviation. And our standard deviation is the spread of a group of numbers from the mean. So again, thinking about the calculations that we did very early on, we were talking about, having our mean, understanding what the mean is, and then using the standard deviation, right, to help us understand how the scores move out above the mean and below the mean. So we'll take our mean and then we'll add the standard deviation, right? And this lets us know what's one standard deviation, or what's the score, the cutoff score for one standard deviation above the mean. We then take that score at the one standard deviation above the mean and add the standard deviation again, right? That lets us know what the cutoff score is for two standard deviations above the mean, and so on and so forth. And then to get those numbers that are below the mean, we will take the mean, we'll subtract the standard deviation. That gives us our cutoff score for one standard deviation above the mean. We'll take that number again, the number that's at one standard deviation below the mean. We'll subtract the standard deviation. That gives us our cutoff score for two standard deviations below the mean, and so on and so forth. So there's the standard deviation takes into consideration the entire group, right? And we use that to determine how dispersed or how spread out our data points or our scores are in relationship to the mean. Our variance is similar in a sense, but the variance gives us the opportunity to look at each individual score and determine how it varies or how it differs from the mean. So both of these numbers will give us some idea of variance and how things are spread out in relationship to the mean. But variance allows us to look at each individual score, whereas our standard deviation look at these numbers as a group and then calculates how the numbers or the scores as a group move out and away from the mean. And again, these are the formulas that we use when we're calculating the variance for the standard deviation. We can actually calculate our standard deviation by taking the square root of the variance, or we can calculate our variance by squaring our standard deviation. But these are the formulas that we will use for that. So we will take our I sub 1, or I'm sorry, our X sub 1. This is each score in our data set. We're going to subtract that from the mean, and we're going to square that number. And then if we're looking at the entire population, we'll use a capital N. And then if we're looking at this in terms of our sample that we've pulled from the entire population, we'll look at N minus 1. But these are the formulas, very simple, very straightforward formulas that will allow us to calculate the variance and their standard deviations. So there's two primary types of t-tests. The first one is the independent sample t-test, and this is what you're doing for your homework. But this is considered to be a between subjects test. So we're looking at two independent groups, right? And we're looking at their mean scores and how the mean scores from those two separate groups compare one to the other, right? So we are looking at males and females. We're looking again at red hair, blue hair. But these are two independent samples. They're not related to each other in any way, right? And again, calculating the means for each of those samples and comparing them one to the other to determine whether or not there's any statistically significant difference. And then we also have a dependent sample t-test, and this is considered to be a within subjects test. Sometimes you'll see it written as repeated measures or as a paired t-test, but this compares the means of the same people. So we're looking at how data changes or how scores change from one point to another point, right? So we're measuring the same group of individuals on 2 occasions. So one of the things that we used to do when I worked in addictions treatment is that we would give a number of assessments when individuals initially came in for treatment. And then we would also give that same assessment once they were getting ready to discharge. And we use it as a way to determine progress or lack thereof during their time at treatment. So what we would do with the dependent sample t-test is that I would look at the scores of everybody who came in. We used to use the addiction severity index. So I would take that score for the group of individuals who came in for treatment, and then I would take that same group and look at their scores at discharge, right? So the same group of individuals, comparing the means of the test at entry and at discharge, right? So within subjects, same people, but we are measuring them at 2 different points. So we're using the mean of the addiction severity index at entry, and then we're using the mean of the addiction severity index at discharge, right? So independent sample, 2 separate groups, right? The mean of group 1 versus the mean of group 2. Our dependent sample t-test, we're looking at the same group of individuals, but 2 separate data points, and we're measuring on the same variable. So I couldn't measure the addiction severity index and compare it to the Beck Depression inventory when I'm doing a dependent samples t-test. It's the same group being measured on the same variable, right? We're using the same assessment. So this is just a quick visual of that. So we're asking people who are flying on vacation about their stress level prior to vacation and then their stress level after vacation. So our very first one, we're looking at an independent samples t-test. So we have 2 separate groups of individuals. We're looking at their scores before, their scores after, and we're making the comparison there, right? As opposed to our dependent samples t-test, where we're looking at the same group of individuals, right? So again, how did you feel before you landed on the island? And how did you feel now that you're on your way back home? Well, and again, that can create some stress, right? Sometimes we're a little stressful when we are heading back from vacation. But again, independent sample between subjects, 2 separate independent groups. Our dependent samples, a within subjects test. We're looking at the same group of individuals who are being measured at 2 separate times, at 2 separate points. So entry into treatment, discharge from treatment. Maybe we're looking at second graders at one math class. We're looking at how they scored at the beginning of the semester, and then how they scored on that same math test at the very end of the semester. Right? So I hope that gives you a better understanding of what t-tests are, why we use them, the different types of t-tests, and again, how each of those can be used to help you better understand the differences between 2 groups. Remember, t-tests, 2 groups, right? Independent t-test, we have 2 independent, separate between subjects design, and dependent t-test, the same group of individuals, but 2 different sets of data being measured on the same thing, right? So I hope that makes sense. If it does not make sense, please get in touch with me, let me know, and we can sit down and we can walk back through it again. All right, I'll see you in the next video.